Well, now
I can stop sharing.
the next speaker is Asim Abbas. Is that right?
I'm presenting on behalf of
Okay.
Asim is my student.
Okay, you are?
Saeed Bukhari, Ahmed Bukhari.
Oh, okay. Okay.
So, you cannot start studying. I think you have to.
I know, I don't know how to do it, but just start your sharing. I know, but I couldn't find it. Go up. You just want to see your slides.
Where do you have the pointer?
I tried to.
Sorry. I don't know. It's okay. It's up to you.
Do you have the
I could, I will see. They did it up, yeah.
A pointer.
Do you have the pointer? No? It's fine. I have to unmute myself as well, right?
Okay, go ahead.
No, I unmute myself because the people are on Zoom.
Yes. Yeah.
Okay, so there is no other. All right, good afternoon, everyone. I think it's the kind of the end of the day, so most of you are tired, and I also been told that Ismail has prepared a very tough question for me, so just wish me luck. All right, so today I'm gonna present our paper. This is actually part of the bigger project of the NSF, and I will first spend like the 10 minutes explaining like what we are doing, and then I will jump on to specific this part, because if I just go directly to the knowledge graph based semantic approach, that would be quite difficult for most of the people to understand what we actually are doing. So let me give you like the bigger picture and a little bit background, and then we move on to this. Okay, all right, so here is the flow. All right, so let's start with the biomedical and the healthcare data. I'm not going to start with the general data. You all know we have a lot of data available at this time, but if you look, we have the two diagrams, your left and right side. So on this side, if you can see, these are the resources where we are producing the biomedical data, and you can see from EHR records to the IoTs to the smartwatches, we have at this time numerous resources where we are producing the data, right? And if we just want to see the overall magnitude of the data that we are at this time is producing, on the other side you can see the data that we have in 2013, and in 2023 at this time, the data that this shows that how fast the data in healthcare and biomedical and medical in healthcare domain is growing, right? More than 1800 large-scale biological or biomedical databases are available, and there are hundreds and closer to millions of papers available, research papers or the reports or relating to the medical literature or contents on the web, right? Now, how it's related to this and how it's related to us. So, the data that we produce in industries, in universities, or in hospitals, specific relating to the healthcare and biomedical data, that data, mostly produced at this time is digitally, and that we store on different the databases or resources, right? And on top of that, either those resources, for example, the PubMed, they have their own interface to search, or the first the way we go to the Google or go to any search engines to write the keywords and start extracting or searching the data. That's the Google is considered to be our first the point to search our data. Okay, now And this is how the general search engine works. Like they have the crawler, they have the indexing mechanism, they have the ranking mechanism, and then we get the results out of that. So consider that they have a sophisticated engine over there, which basically fetch all the new documents which are there on the web, or if they are already existed, then it's try to understand the context of that, and then use different techniques from the pattern matching to the symbolic AI techniques, and and afterwards it rank that, and when we search on the internet, we will get the results. And the search engines are really the powerful at this time. If you see the history, like 20 years back and now, if you see, we pretty much get the results that we want. For example, if we search for the apple pie, it's not only give us the recipe of the apple pie, it give us the calories, it give us kind of the all other related information, and that information is not just coming from one source, it's coming from from different websites. It's just actually understand the context, and it fetch the information, integrate that, and show us in the form of knowledge panel, and you see on the Wikipedia we have the information, and that information is being aggregated semi-automatically and automatically, and it's the different approaches there. But the point is here, the search engines are really working great when it's the general or generic information. Now come to the biomedical and healthcare information. The data, the biomedical and healthcare data, they have multiple issues. Natively, the data that they have is they have the issue with incorrectness. They have the issue incompleteness of the data. The data is redundant. The data, they have the interoperability issues, and also the data which is available, they is seriously lacking the context of the data. It's not like as the medical terminologies are often complex, and it often has very debatable kind of the terminology. I will give you the couple of examples as we move on. But if we see, the most biomedical contents are unstructured and with minor and no explicit machine interoperable tags or semantic annotations. Whatever the medical literature over there, not all medical literatures are completely understandable contextually by the search engines which are available. So that's one of the reason when we go and search for comparing in contrast to the apple pie, but when we try to search for the symptoms of this thing, you have the chest pain, you have maybe you are searching from the complex theory of some medical information, often we get very funny results over there, right? So and that's the one of the reason is that the search engine are not properly understanding the context, and you see kind of the results this, and sometimes so this is a big challenge with the growing information, and the information which we cannot stop that, and information that we cannot manually annotate that, we cannot manually add the metadata or semantic information. We have to use some automated tools which are available. Now there are fundamental technical issues which the tools which are available. For example, if we talk about the semantic tagging, right, and doing the tagging through schema.org, or using the different annotators which are available with the UMLS in the bioportal, or the ontology repositories which are available. So in the biomedical domain itself, other than the technological issues that they have, the terminology level they have, the people are not in consensus. For example, now what is blood? Blood is a tissue, or blood is a body fluid. Some people say it's a body fluid, some people say it's a tissue, both, some say it's both, right? Same as organization. What is, if it is a context, what is organization? Is it organization like the Harvard Universities or St. John's University, or is organization of the body or the organization of the thing. So contextual understanding and the tools, for example, we have a number of annotators are available, like at this time in general, or we have the automated annotators tools are available as well. We cannot do that, the manual annotations and tagging, because of the the growing information. If we have the limited information, definitely that's the like the version, manual version, which we use from the 2000 or early 2000 to 2005. Afterwards, we have different tools, like from the human to the other tools are available. That's the semi-automated way you can tag different kind of the entities. But then there was the wave of the automatic annotators. We have the generic kind of the annotators, and we have the medical annotators. But there are these tools have the limitation and challenges. Challenge is about the speed and accuracy. Those who are generic, they are very fast but not accurate. Those who are accurate, they are not very fast. So the balancing the speed and accuracy is a big challenge with these tools. And you see this, for example, the bioportals, and these tools are developed in 2012, and all the other annotators. Now the COVID came, absolutely, if you don't train them the tools, if you don't put the related ontology, if you don't put the related information, you cannot tag them automatically. The same as, like, for example, if the new terminology, new things come in medical, so you always have to retrain. Similar with the ChatGPT and stuff. I mean, these are kind of the LLMs, these are the trained thing. So I mean, but the knowledge is growing. If I find a new term today and it would be well accepted, I just want to go for the annotator to annotate that. No, it would fail. So the things which we are working on, basically, we are, so these are the challenges with like content heterogeneity, missing any precise data. So we came up with a solution, a socio-technical approach, through which we are basically helping to the people with the technical knowledge, the people those who have less technical knowledge, and those who are not even have the domain knowledge, to create biomedical contents and publish them in a way that would be more accessible and searchable. And our tools have the two parts, like the biomedical content authoring part and the publishing part. So the biomedical semantic content is just like the Microsoft Word. You go over there, you type that, or otherwise you can generate contents through any GPT tools. But the thing is that then it has the different sort of social tools on top of that. For example, we have the Semantically cafe, recommenders, annotators like me. These infrastructures are basically collaborative annotation generator, and helps to, for example, I generate the annotation, I ask to Ismail, can you please check that, is it a correct annotation? You recommend that. If Ismail say, yeah, this is correct, but you will vote on this. Okay, is Ismail is correct or not? Then you will be, so there is kind of just like you see in the Quora, they have thumbs up, thumbs down. So the infrastructure that we have is pretty complex. This is not actually directly related. I have the papers I will show you at the end, but it has the part I can directly jump on the tool. So the tools that we have, we call Semantically. So you go over there, you type the contents, and you hit the button, annotate that. It's used the first layer of annotations, the bioportal tool, and it will give the initial level annotations. Now I go over there and I have doubt about any annotations. I click on that. I will seek for the social help. I need social help for this. So basically, the people, those who are over there, they will, anyone can look at that and can recommend me this annotation. What is the related ontology for that, related terms, vote up, vote down, and at the end, so this is how the things are going. So we have the concept of Semantically cafe. Semantically cafe is just a cafe. You go over there, you ask, oh, I need help, right? So can anyone recommend me a good annotation for this? So these people are saying, okay, we can recommend you, but what are the incentives? We say, okay, so we have the incentive model as well. It's a kind of the social ranking also, yeah, buy me a coffee model. we have the person-to-person peer knowledge sharing approach as well, where I can just ask a specific person to help me in that process. At the end, it goes there, and when you get the 5-star annotations, you publish that into schema.org, and at the end you will see the simple plain HTML, but it's a very good and desired format for your search engines to rank this thing. Now, the specific thing, relating to that, the issue is that how we are ranking that, how the system is working, and how the voting, this thing which I already have explained, how it works there. For example, if you see this on diagram, a new user comes and asks a request for kind of the annotation, like is it a correct annotations or not. So basically, for example, the 3 people reply, okay, this is correct, this is incorrect, or this is, and then the answers of these people are voted by the public. And we have upvote, downvote, we have the self-scoring model. For example, when the Ismail is saying, okay, this annotation is correct, so I asked to, so how confident you are. So it gives the I'm confident 70% or 100% confidence. Then basically our system, we aggregate that at the end different using a Wilson score, an expert confidence score, author's credibility score, and we actually project that in a knowledge graph format. Why we projected that in knowledge graph format? Because this is an easier way for people to look at that and understand how. For example, if you see on this side, for example, if I query that, what is the term for the BRCA2 for the cancer, for the gene for the breast cancer, or the simply it will give me already stored annotations which are recommended annotations, and I can see that who actually recommended this annotation. When I click on that person, it will tell this person already recommended, give answer to this answer to this, and answer to this, and I can see the upvote and downvote about this thing. I can look at the social credibility of that person, that how credible that person is, and what is the history of his kind of the credibility of this thing, and based on that I can go either I should choose this person annotation or choose this person annotations, and we then afterwards, like, we use different scoring schemes, like we use the kappa model, we use like the Cohen and Fliss kappa values to further kind of synthesis this kind of the recommendations. And for specifically for this part, there were 30 participants. These are the numbers, like number of posts, votes, and at the end, like the overall, we evaluated the system like this with socio-technical or without socio-technical, and we see that with socio-technical, the annotations accuracy, we see number of parameters, but speed and accuracy, especially the accuracy part. So 87, the accuracy improves, like 87% to 90% with the socio-technical approach, and gain the accuracy from 65 to 73%. And here are some results. The overall, if you want to see how the system works. So that was the overall thing. Actually, as I said, this is part of the bigger project. So if you are interested, actually we have published a number of papers from this project, like from the decentralized environment to like the socio-technical framework. So all the papers are there. The best way, if you are interested, you can just go to my Google Scholar profile and look at this bigger project. But overall, that we are trying to bridge the digital divide in healthcare using this socio-technical based open source tool. Thanks all, and I would like to acknowledge the student Asim, who worked on socio-technical part, Mutaira worked on knowledge graph part, Sebastian worked on experiments part, and Fazal and myself, we both worked on approach and scoping part, and funds from the NSF and St. John's, and I'm ready to answer your questions. Thank you.
Questions? Don't be shy. Go ahead.
We are waiting for the hard question from you.
Yes, go ahead.
Is there any place for the update of knowledge?
update of knowledge?
Yeah, for instance, today our knowledge about biomedical problem is X, but tomorrow it will be
Well,
Y.
there are a number of places, like it depends on what type of contents. If you are just specifically talking about the research contents,
Yeah.
like Medline, you
Yeah.
have the PubMed. If you are talking about the other, for example, about the genes and from bioinformatics related contents, they have different repositories available, right? So it's depend on resources and sources, and also, you know, it depends on like the consensus of the thing. Some people, it's very kind of the terminology is overall medical very debatable. So the people, they have different kind of the forums available as well other than this.
And when you talk about knowledge, do you talk about knowledge between words or between concepts?
Knowledge between
Words or between concepts?
Concepts.
Okay.
Concepts, and people, because the people, they have different, for example, the people, if the people are working on the blood cancer, right, so they're not, one is their kind of the general or overall knowledge, holistic knowledge about this thing. One is very domain specific knowledge. So when you are annotating that particular topic, the people in plant sciences, they might have the similar kind of terminology, but they are using it in different context. And the people, they are using in different context. And so that's the reason, like if you are annotating the contents with the right semantics, you will get the right results when you type that over there. Because like at the end, we are publishing that into schema.org, which maybe people are familiar, which is kind of a repository, or you can see a tag library by the Google, Yandex, Yahoo. And with that, it makes the information retrieval fast. Yes, sir.
So that's sort of the obvious question. What if some malicious person puts in wrong annotations?
Yes, we have the red flagging. We have in our system.
How would you detect if somebody does it?
Because it's okay. For example, there is one annotation. Just say about the flares conference. Okay, flares. Flare is a word. Okay, I said. See, we have two different environments. Semantically, cafe is a cafe, right? Cafe environment. I asked, okay, so I need the annotations about the flares. So the Ismail reply me, okay, flares mean like the just flares, like the just flare, just kind of the autoimmune flares, right? Or just flare about other thing, and others reply me different. No, it has the kind of the social scoring system. So the annotations of this, you evaluate that, you evaluate that, and we have the score about this thing. Also, you can go over there. So, for example, if you see this, it is incorrect, that you can red flag this, downvote this. So the more
valid score, social score. So if it's the less than threshold, we're going to be red flag. So it's not directly the expert or.
So, yep. So it's a social accountability. Thing, right? With the social accountability, you can judge that whether what's the pattern of this person with not only this annotation, with the other answers as well, and about specifically about it. With social credibility scoring, you can rank, and we can look at the people, those who have this kind of the trajectory to giving the wrong answer, or kind of creating the chaos overall to the system.
Okay.
Thank you very much.
Thank you.
For the last presentation, Casey Adams.